In this presentation we're going to talk about work planning, and as you'll see, it may not necessarily be about work or planning. Innovation is positively welcomed. I'm going to be referencing the lean message that underpinned E3D when it was released a few years back, and being a marine person, my initial references are going to be from the shipbuilding industry, where these ideas have been evolving around that over the last 50 to 100 years. But in AVEVA, we see that as we deal with multiple disciplines of engineering, that these ideas can be applicable all over the place. So the presentation breaks down into 4 parts. We'll have a look at the major changes that have optimized the shipbuilding process over the last 50 years. And this will give me the opportunity to talk about assembly planning, our tool that really helps this process come to be. This will give me the opportunity to talk about specific applications in the marine world and also similar applications in the non-marine world. And it will highlight a need or opportunity for innovation, giving you the opportunity to integrate different pieces of information together. Now, a few years back, when E3D was released, we were talking about the future of plant design and the lean concept, and this was primarily focusing around the ability to reduce some of the inconsistencies that were in your design process, trying to eliminate some of the rework. I guess what I'm talking about is something slightly different. It's trying to make sure that you keep on track, you keep the information integrated all the way throughout your design process, right from the beginning all the way through to the end of fabrication. And this is important in the marine industry because there's so many bits to deal with. We look at this particular example here, we see an image of Hyundai Heavy Industries shipyard. And looking at it, it's a nice picture, but we start to look in depth and we can see many things going on. We see some completed projects in the background, and as we come to the foreground, we see a partial ship, we see bits of a container ship. Beneath the main cranes, we see the bow of what looks like a tanker with other parts of the ships behind it. We can see the bulbous bow that needs to be attached to the tanker. We see a double bottom. We see a lot of cranes. We've got some large capacity cranes, small capacity cranes with different lifting arcs. On the right hand side of the screen, we've got some good areas to transport these blocks of ships around the yard. We're thinking about lean. The yard even goes as far as making accommodation for the workers in the background. So it's this very advanced, very effective business approach. It wasn't always like this. Back in the bad old days of black and white photographs, we used to make everything bespoke. Every part was different. And it was a very time-consuming process to build a ship. But with the introduction or the oncoming of the Industrial Revolution, the arms race that occurred before the First World War, we started to think about how we could build more technically advanced ships quicker. HMS Dreadnought, built in 1906, was one of the first Royal Navy ships to really use this approach. This image was taken 2 days after the keel was laid, and you can see that a significant amount of construction has happened in that time. It was achieved through far more standardization than had ever been achieved before. And this approach is even used today, and it's interesting to make some comparisons. Back in 1906, HMS Dreadnought was a ship 160 metres long, under 20,000 tonnes, and cost almost 200 million in today's prices. It took 14 months to complete. Compare that with a modern Royal Navy ship, we have a smaller, lighter ship costing 5 times more and being delivered 6 times longer. Perhaps this isn't a fair comparison because within reason this type of project isn't really taking advantage of the lean approach. But if we look at the commercial sector, we're having to really adopt this because of the competition in the market. With Queen Mary 2 we see a ship that's twice the length, 4 times the weight, costing only twice as much, and still being constructed in about the same amount of time. And to achieve this with such a large project, we'd have to have made some serious advances in our construction and design approach over the last few years. In fact, with a typical cruise liner, the fabrication at the bottom of the ship is normally being finished before the top has even been designed in detail. So the methods that we've used to achieve this has been increased modularization. We bring those modules together inside often in the northern hemisphere, covered yards where we can control the environment. We have a lot more sort of dedicated facilities, cranes that are appropriate to the workplace that we're working in. We may fabricate parts upside down. In this particular case, this unit has been turned upside down so that the shell plates can be put on. That optimizes the amount of downhand welding, because overhand welding above your head is a skilled welding process. It also takes longer to do. Some cases were like BAE Systems up in Barrow, they're innovating with vertical outfitting. So here we have the pressure hull turned on its side so that the outfitting can be lifted in along the axis of the submarine. So we can see that pre-outfitting during the earlier stages of the fabrication process has been an important characteristic of our change in the shipbuilding industry. It's made elements more modular, but it's also mean that we've had to plan the projects in far greater detail than just assembling them piece by piece. This allows us in the modern world, perhaps in the last 10 years, to do a lot more multi-site working, constructing items in different locations with the digital technology allowing us to do that and allowing us to fabricate things that we can trust dimensionally and then bring them together at an assembly site. This approach even goes as far to our luxury cabins on a cruise liner. It may feel like these have been constructed by fine artisans, but in fact, those artisans may have been working in a factory a long way from the sea. The cabins would have been put on a lorry, trucked to the shipyard, and inserted into the ship like a cassette. It means that shipyards have been turning into far more about integration than it is about fabrication. It's not only shipbuilding that has employed this approach. We see many industries that have gone down the modularization route. It is more efficient. You can control your working environment if you really exploit it. And the business benefits are there to be found. If you can assemble things, details at the sub-assembly level because you're in a very controlled atmosphere, then it's often cheaper and you've got more space to work with. If everybody is trying to work on board a ship, it becomes difficult to get on board, time consuming. And if you're trying to bring large items on board, it can be difficult to navigate them and maneuver them around. So this has been one of the significant things. There's many more once you start listing this. I mean, this is pretty much the whole of my second year at university thinking about design for production. There's so many different things that have contributed and adapted and evolved over the last 50 years in shipbuilding. So at this point, I'd like to introduce assembly planning, which is a tool that AVEVA has created maybe over the last 10-15 years for assisting shipyards in this process of bringing things together. It's worth thinking about how we do this. When we're building a ship, we start with effectively a pile of bits. Individual items have to be cut and put together. So we may take some valves, some pumps, some basic structure and assemble them into a module. We'll take our parts, our sheets of steel, our bars on the panel line and weld them together into our first sub-assemblies. And then we'll go on. We might take the modules and insert them into a unit. We'll build more complicated panels. Those panels will get turned into blocks and ultimately they'll be erected at the ship, in the building dock. What we're building here is a tree of items that have to be linked together. These items exist as digital items in our design tools, ultimately representing the nodes of this tree. But equally as important are the edges. These represent the work, the resources, the instructions that you have to put this project together. Looking at this another way, this is our work breakdown structure, the tree. But in the design world, do we really work with this? Often we're working with a slightly abstracted way of looking at our data. It's what the software wants us to see. We have to consider the way that information is stored, the way that it's distributed around our workforce, the way that we control it. It can be the case that we start out thinking that we'll build it one way and halfway through the project we'll need to change that idea and build it another way. And it's difficult for our data model to necessarily adapt to that process. And this is where assembly planning comes in. It allows us to link our design world to our building world. We can take our design model and through the assembly of digital components we can determine what we're going to build. how we're going to build it, where we're going to build it, and the information that we need to do all that together. In fact, it's a very simple process. As I highlighted in the previous slides, it's a tree. When I actually create the assembly plan, it's just a tree of items. I create a tree in sort of software terms, and I link the items from my 3D database to it. It's this simple that even to demonstrate it would perhaps degrade the power of the tool itself. In the design tree, the design explorer, it also exists as a tree. So it's very simple to interact with. It pretty much is nothing more than this, but it has potential power for managing our project. If we think about it, the designer is creating our parts and may, if he's experienced, assemble that into an assembly. Now that assembly has an identifier, and that identifier can be passed to production where they can evaluate that assembly, make changes of their own. That information can also be passed to planning, and they can review that assembly, understand where that fits in the grander scheme of things. So what we've created is a means to communicate between each of the departments within our business, a way of controlling the information. In fact, the assemblies start to become part of the language that we use to communicate where we are, how it's going, and what status we're at. Now let's have a look at an assembly itself. It is, of course, a selection of parts, or perhaps other assemblies. It brings them together into the assembled form. And once we've done that, the digital information that we have allows us to understand the weight, the size, and the logistics that are involved with bringing this together. From that, we can determine our planning characteristics. From a shipyard point of view, we can identify the workstation where it's going to be built and the orientation that it needs to be built in, because it might be upside down, it might have to be laid on its side if it's a strange shape. Along with this, there's no reason why we couldn't use the power of the software to associate our documents with the assembly node, the drawings that represent the assembly, and the work instructions that we're going to use to put it together. So this is a very powerful concept, considering that as far as the data structure goes and the way you create it, it's just a simple tree data structure. The potential applications of this go beyond really what it was designed to do. It of course fulfills the idea of a construction sequence, although these days many people are thinking about construction sequences in terms of animations. Assembly planning does this as well, but the depth of information inside of assembly planning can be as much as we want to build. Ultimately, we're trying to represent work in terms of the instructions to build something, or the packaging of how we're going to put all of this information together and give it to our labour force, or the planning, how we're going to actually put all this together beforehand before we get to packaging. So the ideas with this could be quite wild, could be beyond the typical production scenarios that we're normally dealing with. It's supporting the document associations. We could think about using standard assemblies so that every assembly is not bespoke. We can make standard parts for those assemblies. It addresses the need for palletization. Assembly tells us what parts are going to go in the packaging with the work instructions and sent to a work location for fabrication. So potentially the ideas of where I'm working towards is that though this is the way that this system is set up, there are more ideas that you can use it for, and certainly in shipbuilding and perhaps in the other industries there are other ideas that this could be applied to, and I'll come on to them a little bit later on. So assembly planning is set up for this kind of idea of setting things together. Let's go into a little bit more detail as far as how these can be applied, some particular ideas. This is a diagram of a ship. You can see that it consists of basically rectangles and shapes that have an identifier. This could be something that you produce in the early phases of your design process. Your design process will be working with a plan of how this gets fabricated. And obviously we're at an early stage here. Perhaps we haven't even created a 3D model. So at this stage there's nothing stopping us from creating an assembly tree that represents the plan of how this will be put together before we've even considered making a 3D model. The thing is, once we start this, we have something that we can talk around, something to communicate. It establishes information that our designers can use and associate with. They can contribute to the assembly planning tree with the 3D model, which then goes on to the construction process. They can utilize the assembly planning tree. So what it means is, like, for your project, it's a bit like a stick of rock which says assembly planning all the way through. We can carry this piece of consistent information all the way through our project process. Now looking at kind of the end of the process towards construction, which is where we start to use the maximum extent of the information within assembly planning. The assembly within the application itself can create drawings using automatic drawing production, the sketches. We can use the interactive reporting tool to create a report. Within this is pretty much the extent of the software application called assembly planning. But now we can utilize the information within it, which takes us outside of assembly planning. It tells us what parts that we have to nest to allow us to do the plate cutting. Similarly, with the bar cutting, we get the same information. Now, I spoke earlier about the identifier. The assembly has a name. Individual parts within that can be named based on the assembly. We have a kind of a naming scheme. With modern cutting systems, they also have the ability to mark. So we could put those names actually on the parts, so that when that part is produced and picked up, we know exactly what it is because it has the name of it, the assembly name and the part name. Gather those parts together, they can be put on a pallet, which represents the assembly with the documentation from the assembly. Extending it further in some more lean kind of invested shipyards, assembly planning has another module called world planning, which identifies the junctions between parts, the things that you need to bring together to make it. These are identified as database information, geometrical or geometric traces, which can be used to power your robot welding. So in this kind of picture, we have a very lean process, perhaps the process that somebody like Hyundai uses. But not every customer will go to this extent. It depends on whether they can utilize standardization to the fullest extent. But they can still pick and choose from different aspects of this to make the best way that they have within their style of projects and their style of facilities. So at this stage, we got a bit detailed at that point. It's worth stripping it back and recapping what we've got. So we're dealing with a simple tree work breakdown structure. It's just a tree. That tree references the 3D elements in our project and supports associations to documents that tell us how to build the assembly, and may incorporate attributes which are important to the assembly itself. So ultimately what we have is, compared to other solutions that we could be using, it's a simple solution to a problem rather than some massive investment that might change your business. And because of that, it can be very easily integrated in your project and very agile with the way that you use it. And because it's a very simple process that gives you the ability to discuss and communicate, it can powerfully initiate other processes. Today, assembly planning is not yet available in E3D. With the integration of the marine functionality into E3D over the years, it will come. And because E3D is very much an agnostic tool, it will give other domains of engineering the opportunity to use this in their projects. And that's something, as we talk to customers, something that they're interested about. But we also find, as we talk about these kind of things, areas where they're already using this kind of approach, but they're not necessarily calling it assembly planning, and they're not necessarily doing what assembly planning was designed to do. I'd like to talk about some of those scenarios. One of them, my colleagues have informed me, is called the secondary hierarchy. A similar idea with a work breakdown structure which connects, in this case, the drafting world with the design world. The designers are creating the 3D parts. They may be all over the project. The drafter might not necessarily know the context or the position of these parts. Together they can work on an assembly. In this case, it's a group set, where they assemble the information and give the 3D information some context as far as drawings are concerned. In fact, we're building draw lists here. And those draw lists can then directly be used on a drawing without too much understanding about or need for the drawing person to go into the 3D model and collect parts. Another opportunity is through engineering. In fact, there's so many opportunities with engineering. Two particular examples, one a shipbuilding case, one a non-shipbuilding. There's a shipbuilder that wanted to create exactly the tree that we get with assembly planning, collecting work instructions, but the challenge is that they wanted to create a very detailed tree of instructions, not necessarily consisting of parts. And because assembly planning is very much focused around the 3D side, they couldn't do it in assembly planning. So they built their own tree in AVEVA Engineering and collected information that could be displayed in the 3D world, but in the tables gave them a lot of functionality which the standard assembly planning application doesn't have. Another non-shipbuilding situation is a plant customer in the US that was using AVEVA Engineering in a tree-type structure to make work packaging, I think work-face planning they called it. Being able to collect 3D models and the drawing instructions, work instructions, other information they needed together so that they could run their maintenance systems on a day-to-day basis. So you can see that the ideas for trees and connecting people between different worlds is very powerful in this approach. And that's when I said at the start, assembly planning might not necessarily be about work or planning, it's really down to the kind of innovations that we make. And often those innovations require customization. So it's all about extending the solution, and our software allows you to be able to extend it without any interaction with us often. So from an assembly point of view, assembly planning, if you wanted to extend the assembly tree to capture other information and do things that we didn't think of, you could of course user configure it to do that. Similarly, with the second hierarchy idea, you could take a group tree and configure it in the same way. In actual fact, there's a significant relationship between these two areas. If you look at the way that the assemblies are stored, their attributes, you'll see that pretty much they share everything that the group has. The only difference is that there are some additional rules with assemblies that make them behave differently to a group. You can only include a part once in its assembly tree. And then you have the AVEVA engineering solution, allowing you to build a tree of engineering items through user configuration. So you have three similar solutions that you could expose the information in your project. You could do all three, you could do just one. There's a lot of commonality behind that. And while that may help you achieve some leanness in your project, as far as we look at it with managing our software, this causes some complexity. Perhaps we're not looking at this in such a lean way as we could be. So there's some opportunity for some consolidation in this. But we don't get that without talking to our customers. So this is where, and we'll come to the opportunity at the end of the presentation to ask this, is whether this sparks some ideas in your head as we've been going through this. Whether that gives you some fabrication ideas, or planning ideas, or ideas about something that I've not even covered that is important to you, that you can see can be solved this way, but I'm not necessarily thinking about. We'll take this one step further and look at other ways that we can innovate our products. Perhaps this is an opportunity. Once we start to look at our products that are actually involved in fabrication, we see a lot of commonalities between them. Marine has assembly planning. If we go to the BOCAD product, we also see that it has an assembly concept. Looking through the documentation of FabTrol, it also references the idea of assemblies. In the future, E3D will also get the assembly planning concept as we might move forward. With AVEVA ERM, they also have the same concept, but being Danish, they called it kitting. AVEVA engineering can also be used in this way, but you have to build the entire solution yourself. And of course, outside of our products, our customers are using third-party tools like Primavera, where they can also build trees and do slightly other capability. Now, referencing the fact that what we're creating here is a really simple tree structure, wouldn't it be nice if we could have an idea of that common assembly model, like the words running through the stick of rock, through all of the different applications some kind of interfacing. This is something that is my personal idea of how this could be done. It's something that could be explored more between you, the customers, and our internal team. So closing out the presentation, we've seen and discussed how the lean concepts have greatly enhanced shipbuilding over the last 50 to 100 years. It's been achieved through innovating a simple idea. There's been powerful changes to the fabrication process, and AVEVA has been able to contribute by allowing them to connect the design world to the 3D world using assembly planning. But now, as we'll give you in the future the opportunity to use such a tool in E3D, be interested to see what you think of this concept. Thank you very much.